Going. All right, so we're in our number properties booklet. You may not have finished everything, obviously, in your other booklet, though I'm hoping to come around later and see how you went with the pages over the weekend, those of you that had a little bit to do. If we have extra time, I may ask you to fill in a few more things from that booklet, but we do need to go on to this next one. Now, normally we would have 3 lessons this week, but the swimming carnival is stealing one of them. So we will try to get through a little bit of extra today as well. All right, so the first thing we're looking at is prime numbers. So to save a little bit of time, I'm going to fill in most of this table here for you instead of getting you guys to help me. And what I'm going to do is I'm going to be thinking of the times tables that I can think of to make each of the numbers that are here. So first of all, for the number 1, the only way to get 1 from a times table is to do 1 times 1. That's it. That's my only option. For number 2, I could do 1 times 2. That is also my only option. Please be writing these in as we go. Okay. Number 3, we could be doing 1 times 3. That's it. Question number 4, it gets a bit more interesting. We can do 1 times 4, but we have a second option. We could also do 2 times 2. Number 5 is 1 times 5, but that's it. There's no other times tables that give me 5. 6, I could do 1 times 6, or there's a second option, 2 times 3. Number 7, 1 times 7, that's the only option. 8, I could do 1 times 8, or I could do 2 times 4. 9 could be 1 times 9, or it could be 3 times 3. 10 is 1 times 10. All of them, it's always 1 times, so we can always have that one. And we could also have 2 times 5. 11 is 1 times 11, but there's no other options. 12, we could do 1 times 12. We could do 2 times 6, or we could even do 3 times 4. There's 3 different timetables that could make 12. 13 is 1 times 13, but that's it. 14 is 1 times 14, but there's a second option. It could be 2 times 7. 15 is 1 times 15, or it could be 3 times 5. 16, 1 times 16, or 2 times 8, or 4 times 4. 17 is 1 times 17. That's it. 18 is 1 times 18, or 2 times 9, or 3 times 6. 19 is 1 times 19. And the last number, 20, we could have 1 times 20, we could have 2 times 10, or we could have 4 times 5. Now, what this table does is it lets us have a little bit of a conversation about factors, about how many things can be divided out of a number. And there are 3 different categories that we are going to look at, which is in this table down here below. It says, using the information from above, put the numbers from 1 to 20 into 3 groups and justify your grouping. The first group is a special one. From that table, there is only one number in it, and it is the number 1. Have a look at this table. What is special about the number 1 that is different from anyone else? It's Byron, right? So only 1 times. Yes. It has only one number used in there, and it's the number of 1. So it's 1 times 1, but it's only 1 that we're using. Everything else has at least 2 numbers and sometimes more. Okay, so it's special. So number 1 has only one factor. And it is the number 1. One factor, which is the number 1. Group B is going to be all the numbers that have 2 factors. So all of these ones in here that had 1 times 2, 1 times 3, not these ones that had extra ones. So 2 has 2 factors, 3 has 2 factors, 5 has 2 factors. All of these ones that just had 1, 7 has 2 factors, 11, 13, skip a few, 17 and 19. Okay, so let's write all of those down. It was 2, 3, 5, 7, 11, 13, 17 and 19. These ones, they're the ones that have 2 factors. And the 2 factors are always 1 and itself. So for 5, it was always 1 and 5, and 1 and 7 for that one, and 1 and 19. So whichever the number was here is always that number and the number 1 that makes the 2 factors. These ones have a very special name. These are called prime numbers. Okay, so numbers that have exactly 2 factors, itself and 1, they are our prime numbers. The part C, the group C, are the ones that have more than 2 factors. So these ones here that had a second group or even a third group. So we started with 4 is the first one that has 1, 2, 3 different factors. We don't count the 2 twice, just count it once. So it has 3 different numbers. This one has 4 different numbers. So 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20. Let's write those down here. 4, 6, 8, 10, 12. Oh, I missed 9, did I? Thank you. Better go back. 8, 9, 10, 12, 14, 16, 18. Did I miss any more? Oh, 15. I can't see my table at the same time. That's my problem, isn't it? 16, 18, and 20. Okay. These ones has more than 2 factors. And if something has more than 2 factors, its special name is composite. So we have prime numbers and we have composite numbers. But the number 1, and if you have a look on the next page as well, it also says, and the number 0. 0 and 1 aren't prime or composite. They don't have a name. Someone should have given them a name that was something else other than prime and composite. They just don't have a name and they don't have a category. They're not prime or composite. So on this next page, we're kind of going through that again. It says complete the table and give a definition. So the number 0 and 1 are neither prime nor composite. And then a prime number, we're always talking about positive whole numbers. Okay, we can never have negatives, we can never have decimals. So we're talking about positive whole numbers that have 2 factors, which are 1 and itself. So there's 2 things. They are positive whole numbers and they have 2 factors, which is 1 and itself. Whereas the composite numbers have more than 2 factors And the other interesting thing about the composite numbers is that they are all even numbers. All the even numbers are composite except the number 2. There are other numbers that are composite that aren't even, but every single even number is a composite number except for number 2, because 2 is just 1 times 2 and it only has the 2 numbers to make factors. So as soon as you see an even number, if it's not the number 2, you're going to know it's a composite number. Okay, it's one way to tell. All right, next part. Number 4. Oh, I've just given it away. What is special about the number 2? It's the only even prime number. Okay, so first of all, let's say it is prime. It is a prime number, and it is the only even prime number. How are you guys going? Keeping up okay with the writing? Great. Question 5 is where you're going to grab your computers out. So when you're ready, open up your laptops and it says research the following. I want to see who can give me a definition to help us with these. It says I want to know what an ascending prime is. And if you can give me an example of an ascending prime, that would be good as well. So you can just type that into a Google page. Just type in ascending prime and it should bring up something for you. No, you're just going to just open up a internet page and type it into your search. Just type in ascending primes. All right, so who can tell me? Let me know when you've worked it out. Seb, what is an ascending prime? Yes, yes. Yes, good. I think you've got it there. So the digits in the number are in ascending. Now, ascending means smallest to largest order. Now, did anyone come across an example of a prime number? It has to also be prime that is an ascending prime. You could think of maybe, look back at your numbers 1 to 20, because there's a few of them in there. The number, so for example, number 13, that's an ascending prime. The first number doesn't have to start with a 1, but it is smaller and 3 is bigger. So the numbers are getting bigger. Does anyone know another one? Yes. 16? 16 is not prime, unfortunately. It is ascending, but it's even, so it doesn't work. Roman. 17. All right, use your computers. Can you find a 3-digit prime? Yes? 317? Yeah, probably. You have to check. I'd have to check all of them. The ones I had written down, I had 347. I just picked a few out. I just found a web page that listed 100. No, because it goes down again. 101. The numbers have to be getting higher as you go along. Did you find one? And the 7 goes down. So the numbers, it might be prime, but you need the numbers to be getting bigger as you go along. Did you have one? You had a 113? 149, that works, yes. All right, so I'll write a few down. So I also had 1, 2, 8, 9, 3, 4, 5, 6, 7, 9. That was a big one, 6-digit prime number. Seb, you have more, do you? 2, 3, 9. Yes, that would work. You'd have to check because not everything that ends in a 9 is prime. So 49, for example, could be divided by 7. So you do need to be very careful. You got more? I don't need more. I think we've got enough for now. You're going to tell me more? That's okay. Do you have a question or you have more? No more. No more. That's enough. We've got enough. All right, cool. So we know what an ascending prime is. As we look at the numbers, the digits are getting bigger as you go from left to right. Okay, what is a palindromic prime? Yes. Parallel, not the same. Kind of. Does anyone know what the word palindromic means? Yes. No, not descending. Palindromic means the same forwards and backwards. Okay. So I'll write it down. First of all, it has to be prime again. It has to be a prime number. It is a prime number that, yes, that reads the same forwards and backwards. So a nice, easy, small one would be like the number 11. Doesn't matter if you reverse the numbers around, it is still a prime number. And it is palindromic. You could have 101, the boy suggested at the back, or 191, 111. Okay, there's heaps of, all right, great. There's heaps of them. Okay. Actually, here's a really big one for you. 1, 2, 3, 4, 9, 4, 3, 2, 1. Look at that. The 1s, the 2s, the 3s, the 4s, and the 9 in the middle. That is actually a palindromic prime. Okay. So that is where I'm going to stop the theory part, and I want you to do a few things for me. So I'm just going to stop the video.